Streaming media is multimedia content that is simultaneously received by and presented to an end user whilst it's still being delivered. Streaming media usage has increased exponentially over the past few years for entertainment purposes, marketing, support for products, services, and many other reasons. Streaming presents two key challenges: adaptation of content for transmission over networks, and maintenance of a constant, stable transmission rate. Research shows that real-time entertainment traffic is increasing its network dominance, particularly in North America, where it represents nearly 50% of peak period fixed access traffic. Additionally, the internet is increasingly being used to provide live coverage of major events. According to Cisco, it would take over 5 years to watch the amount of video that will cross global IP networks every second in 2015. Internet video to TV tripled in 2010, and IPTV will continue to grow at a rapid pace, increasing 17-fold by 2015. The level of all forms of internet video, TV, video on demand, internet, and P2P, is projected to increase to approximately 90% of consumer global internet traffic by 2015. You may think of video files as AVI or MP4 files. In reality, these are just multiplex container formats, similar to RAR or ZIP formats, and they can contain any sort of file. A video file usually contains a video track without audio, one or more audio tracks without video, and some metadata such as subtitles. When you watch an online movie, your video player first interprets the container format, for example MP4 or AVI, then decodes the video stream according to the video codec. Finally, it displays a series of images called frames on the screen. Modern video codecs can minimize the huge amount of information required to display the frames. Instead of storing each frame individually, intraframes and predictive frames, or I and P frames, are used for encoding. I frames contain the entire picture, but P frames only contain changes made since the last I frame. There are lots of video codecs. You may have heard of DivX and XVID, which are MPEG-4 implementations. The WMV family and VC1 are Microsoft-based, with VC1 evolved from Microsoft's WMV9 codec. The VP3 codec was developed by the Theora project run by the ZIF.org Foundation. Scalable video coding is very interesting for the future of video coding because it can be classified as a layered video codec. This means that the video stream is simultaneously encoded into and transported as several high-quality layers. SVC provides a base layer and one or more spatial, temporal, and/or quality enhancement layers for the effective adaptation of the video rate to the available network rate, in return for some reduction in compression efficiency. Like video codecs, audio codecs are algorithms by which audio stream is encoded. Audio compression works mostly using psychoacoustics, the scientific study of sound perception, which provides high-quality signal compression which safely removes inaudible sounds. You should have heard of the word MP3. AAC, Advanced Audio Coding, was designed to provide better sound quality, and it can encode audio at any bit rate. As we mentioned earlier, in order to send audio and video at the same time, both streams need to be multiplexed. Advanced containers are able to multiplex video tracks, several audio tracks, subtitles, and metadata streams. These tracks are usually interrelated. An audio track contains markers to help synchronize the audio with the video. Some of the most popular containers include MPEG-PS, MPEG-2-TS, MP4, AVI, ASF, MKV, OGG, FLV, and MXF.